Yo, what's up everybody, how's it going? So today we are going to solve one of the another coolest problem, symmetric tree. Yeah, you hear the right thing. This problem is symmetric tree. So basically what this problem says about we have given our root of binary tree, check whether it is a mirror itself. So basically symmetric means, like, for example, let me just give you a very simple example, you will understand if you don't know. Just a quick recap. So for example, if I have this word H, if I put mirror over here, okay, if I put mirror over here, the mirror image will come similar like this over here. This is symmetric. But for example, if I use D and I put mirror over here, then the similar image will not come. Yeah, so similarly we have to check whether this binary tree is symmetric or not. Symmetric means like this 2 has to be 2 over here, this 3 on the left has to be 3 on the right over here, this 4 on the right has to be 4 on the left over here, is like that. Alright, so how we're gonna do is I will show you two methods to do this problem. They both are like time complexity of O, and so they run very good. Alright, don't worry about that. One is recursive and another one is iterative. Alright, so it's all up to your choice which one you want to use. So like, no personal suggestion, but like, yeah, if you know two methods, then that will be good. Just knowing is very good. Alright, so yeah, let's just start. So first of all, I will gonna use recursive method. For that, if you look at the problem, then like I don't have any way to break this root into two different parts so that I can check. So what I will do is I will create one function and I will return it. So for example, I will create return mirror. Let me just write in camel case, mirror tree. Okay, so I will call it root. So I want root. From this, by doing this thing, my root is break. And let me make one base condition as well. If root is null, then I will simply return true. Okay, so like if we don't have any like children, we just have only the root. For example, if we only have the 1, then we just got the 1. Yeah, it's fine. It is symmetric. Alright guys, so let me just make that mirror tree. Alright, I will call left tree as T1 and I will call right tree as T2. Alright guys, here we go. So now what I have to do is I have to first of all check if the T1 is like, I'm just checking if T1 is equals to null and T2 is equals to null, then I will simply return true. If T1 has some value, like if T1 value is not equals to T2 value, then I will return false for that. But if like T1 is not null and T2 is null, then I will return false for that as well. Like similar, like if you know the previous one question which we do, same tree is similar to that. If you don't know, then just please go and check out that video. So let's get moved into this video first. Alright, so, okay, so I will create if is to null and T2 equals to null. For this I will simply return true. Alright guys, I hope you understanding what I'm saying over here. If you have any doubt, then just rewatch this video, it will help you. So what I'm doing over here is, for example, if T1 is not null but T2 is null, or if T1 is null but T2 is not null, then what will happen? It will simply return false. So I don't have to like put every single condition for the both of them. So because the OR condition helps to manage, because if anyone get false, it will exit the function. If just depend of anyone. All right. Okay, so let me just okay, so now I have to check is the values equal. So what, like I will simply put that one in my return statement. I will say return T1 is equals to T2, T1 dot val equals to T2 dot well. Okay, and what else I will check? I will check, is our mirror tree left is equals to right and right is equals to left. Mirror tree t1 dot left comma t2 dot right, and we will say t1 dot right comma t2 dot left. Okay, and just simply close it. Let me just give a run hit. Yes, it's going. Let me just submit it, and here we go. Yeah, so this is the recursive, like a recursive approach which I have done. Now let me just do a iterative approach as well. So it's very good as well, the iterative one. So how we're gonna do is, let me just reset to default. All right, so for that I will just simply use the help of the queue for this. Okay, so what I will gonna do, I will create my queue over here, and I will call this at queue. Okay, you can call it whatever, so I just call it queue, simple. Okay, and then I will just say a new linked list. Okay, alright guys, so now what we're gonna do is, I will similarly break the root. So how I can break the root is, I will simply say quick dot add root. Guys, one more thing, like if you don't want to see the second approach, you can leave the video, I don't mind. So but it will be better if you watch it, so it's all up to you, no forcement. Right, q dot add root. Okay, so over here we just break our root into two parts, so by adding it. Now what I will do is, I will simply make one like t1 and t2, I have to make them as well, so I will do that thing as well. So I will just say tree node t1 equals to, and I will say over here q dot poll. I will explain you what does I mean by saying this. So basically what this poll function is do is, basically it will return or remove element from the node, and it will just take an example. Okay, let me just explain you with the help of pen. Okay, for example, like if we are talking about 2 and 2, so this t1 and t2 dot poll, what we'll do is, they will return 2 from the linked list. You know the linked list we created, so they will return from over here, and they will check like, is they are similar. You get my point? If they are similar, then we will return true, otherwise we will simply return false. That's all what we are doing. So let me just erase it. Okay, so I will simply again check if t1 is equals to null and t2 is equals to null, then I will simply now I will not return, I will just continue to check. I will continue. Okay, now I will go for like if t1 has something or t2 has don't have. If t2 has or t1 don't have, then for that, so I will return false over here. Alright guys, now I will create one if the value are different. For that, if t1 value is not equals to t2 value, then okay, then I will simply return false. Alright guys, now in the end, okay, so one more thing I forgot to tell you, like we are doing this thing in the while loop. So why we are doing this thing in the while loop? Because we are putting in the linked list. Okay, so we have to check if q is not empty. This while loop will run if q is not empty. If q is not empty, right? So that's my mistake, I really apologize for that. Okay guys, so now what else we have to check? We have to check so how we gonna check our now the left and right one is, I will just simply add it to the queue. So I will say q1 dot q dot add, sorry, q dot add t1 dot left, then for the right t2 dot right. Now for the t1 right, now for t2 to the left, and finally we will return true in the last. Don't forget to return true. Alright, let me just give a run hit. I hope this queue is making some sense. If you're finding any difficulty, then you are good to go with the recursive one as well, so don't worry. Alright, but this is not nothing hard. It's similar like that. We are just adding in our queue. So you know how the queue work. In the queue we have to we get first in first out. So if you remember queue, that will be great. Otherwise it's not a problem. I will tell you somewhere in next video. Alright, so let me just give a submit hit to this, and this thing is like okay. Alright, it does not matter because like sometimes it's happened. Runtime, don't focus on runtime, but the runtime complexity of this is similar on. Alright guys, I hope this thing makes some sense. So if you guys like this video, then please make sure to subscribe the channel. So your effort make me feel proud to make more videos. So thank you very much guys for watching this video. I will definitely see you in the next one. Till then, take care, bye bye, and I love you guys.